examples that I'll give you for the change and how you can show it. For clustering, have you ever used clustering to like for any of the metrics or?
Yeah.
Yeah, so it's a collection of data points with a like similar or dissimilar values, and then just showing where they are, right? Like you have on Y and X, you have like the measurements, and then you showing this is where majority like of let's say these are the women in their 20s and 40s and 50s, and these are the different points of like maybe it's like different brands, H&M and Zara and YSL and Chanel. And then with the clustering, you can show where do most of these women shop depending on their age. And then you're like, oh, well, majority are still, here in the, maybe in the middle, maybe not. In this case, you look at it and it looks like in the middle, whatever that, is like majority of users are. Um, for one or the other reason, right?
Mhm.
So relativity. Basically, here we see pie chart. Probably everybody used pie chart before, 100%. So it's basically it's related, like how it's related to how one point is related to another. Usually, when you think about pie chart, if you have like 100% of something and you are breaking it down, use pie chart. Let's say out of 100 people, or 100 people, 100%, and let's say it's uh, let's say
So
30% of
pie chart. It's like when
this is
you
a
have like
pie. This
some.
is called pie
Ah,
chart.
yeah. Sorry,
Pirog,
I got
so like then you
I
have like different
misunderstood.
slides.
Yeah,
Mhm,
sure.
mhm.
Sorry.
Yeah. So and relativity is for observations considered in relation or in proportion to something else. And we'll go through that one. And then we have ranking. So position in the scale of achievements or status. So like whenever you see all these like let's say especially news, you see a ranking of different countries, like by specific let's say um, by their economy or by their healthcare, you can see different ranking. And there's a couple of other examples of how to show ranking. And then correlation. So mutual relationship or connection between two or more things. So they're kind of similar to clustering, but in correlation, the difference is oftentimes there's like one is you're just comparing two things usually. So versus in clustering, you can have a bunch of multiple things. So here are more examples. So if you look at them all, which ones would you say you haven't used much? Or which one is interesting to you that we want to like touch on?
Well, I would go with the spider web and all of them that's down like box, spot, word card, like
Mm-hmm. Okay.
Sankey, like this.
For
Yeah,
me,
this Sankey is the one that I never use for my work. But if you're like into what is it called? You're like a bioscientist or
but
something, right?
biotech,
You saying something then?
biotech, you mean?
Not necessarily. You're like, you're taking analytics of the ocean, like or the quality of water and things like that. A lot of
I
times they're
see.
using these more complex ones.
Mhm.
In product
But
management, yeah, go ahead.
what we need to go with.
There we go. That's a thing. I would say with as a product manager, you will oftentimes use a tree map. Pie chart is a must. Line, yes, you'll use it. The columns I use all the freaking time. Um, do you know what this candlestick is?
Not really.
Tanya, what do you use candlesticks for?
Uh, when in my when I was a student, the last course, I took a course with how to say it, like birja trading.
Yeah, there we go. Yes. So finances. So stock
Yeah.
market, this is super popular now. Now you'll be noticing when you watch news. So the candlestick is showing you, this is usually per day or like maybe per week, but on the X. On the Y is going to be the measurements of, let's say it's points, right? Or like how much money it is. And for each day, let's say you will see the lowest point and then the highest point during that day. Let's say it's S&P 500, the
Okay.
lowest point of the day and the highest point, and like that. Um, you won't have to use it much at all. It does depend on your product. If for example, your product is, if you're in fintech, you might be having not necessarily a stock market, but some similar things might be happening. It's just good to know about it. You're not going to be using it much or at all. Sometimes you would use double bar, but again, very rarely have I seen that. I remember using word cloud like at university, but we didn't ever use. I think at a startup you would use that when if you're trying to get some feedback or you're collecting the feedback and seeing what our customers are actually saying more or what are the most popular uh, words that they're using. This is where if you run it through SQL, you could see the set of most popular words, and then it can create a word cloud for you. Yeah, so tree map. Have you ever used tree map?
Yeah.
Okay. So
No.
tree map, it's funny, it doesn't look like a tree at all, but the point is that um, you basically have these buckets as squares, and it represents, like, let's say it's 100%, or it could be $10 billion, right? And then this would be 5 billion, and this would be 5 billion, right? So like they oftentimes are correlating approximately, showing you and the uh, the like the numbers are and the sizes should be proportionate to the numbers. And then they oftentimes use heavily color coding to show, like, for example, in I'll actually walk you through example that is like more real and
Is
it will be
this
easier.
business canvas proposition or whatever we do is in this model? No?
No, because there's no numbers, right? It's just convenient, but it does look like it, but it doesn't use the tree map. And we have a couple of slides I'll show you through like real examples, and it will make more sense and you'll remember it better. But basically, there's categories of data analytics. Some are descriptive, some are descriptive is kind of easy to understand. Inferential is basically you take like a sample of something, and then the sample represents the entire picture. Then again, like until we go through the examples, it's harder to remember, and I will be sharing the slides with you. So as you tend to see different metrics and boards at work, now you pay attention to it, like, this is that one, and this is why they use it, just have it as an exercise. Exploratory, so usually, again, as we pointed out here, right, the columns, usually use it when you're researching something and you're showing the difference. So why do I use it? One of my very important metrics is ASAT, so agent satisfaction, kind of like customer satisfaction, which is CSAT, right? And for each of the products and for each of the months, I show it in this diagram. So if I want to show one like Xbox, for example, and like March, or February, March, April, May, then I will just do it this way, in one. But then if I want to have Xbox and I don't know, ads and surface, I could still use columns and just color code them for each of the businesses. I'll have different color. Or I could also use histogram. And this way I could show like my months in here. And then each of this, column will represent a business. And then I'll have March, February here, and then I'll show the sizes. So different ways to go about it. I use the columns because it's very easy. But again, point is that when you are doing the exploration and just showing the progress of like your product, for example, you can use these graphs. Causal gold standard for data analysis utilizes correlation and regression to explore data relationships. So it's usually when you're trying to relay the reason why something happened. Remember how last time we went through like different metrics. One is the North Star metric for Spotify, and it's the number or amount of time a user is spending per average on Spotify. But then there are also supportive metrics that we're after, like daily active users, right? And if, for example, we're seeing that one of the metrics is down, we're going to be looking at all other metrics around. And this is oftentimes helping us to figure out why did this metric drop, right? And so in that case, so the category is called causal, but it would be a set of metrics that you'd be showing on one slide to show the story. And that's another thing that I have to mention. In reality, we're supposed to be not biased as product managers, but we're just humans, so we oftentimes are. And so especially when we go to our boss, we try to show things nicer than they might be. And we're like, I'd rather show these 3 months, not 6 months. Because whenever it's like 6 months, maybe my previous 3 months of customer satisfaction wasn't as good. So if I show 6, then it shows like the lower percentage. But what I can do, I can also create a different messaging of showing, hey, it's been 6 months. Remember, it was down months 6 and 5, and then we rolled out this feature because it was actually what the customers were asking for in the feedback. And as soon as we rolled it out, look, the customer satisfaction is growing. So again, you're the messenger. A lot of times our job is not to manipulate that data, but do we? In reality, sometimes a little bit. Again, I'm here not just to tell you things by the book. I'm just telling you how like reality is. And so when you go to a meeting, right, especially in corporate, like you gotta save your butt, and that's another reality. So even if the numbers are bad and you have to still deliver that, you can message in different ways where it's like, well, these are things that we've learned, and hence, look, okay, let's say I have another situation. I had higher customer satisfaction numbers, and then suddenly it dropped. And so now I'm like, fudge, I have to go and present the fact that, it's going down. Why is it going down? Then I'm looking back to other metrics of like what has changed, what was the feedback? Oh, we haven't been responding to that feedback for like months, right? And so it's gotten worse and worse. Or the feature that we rolled out like has a terrible user experience, and now it's not helping the customer. All different ways, but then at least when you're telling, my point is, even when the metrics are down, you need to be able to look at other related metrics that we talked about, right? Because you already have that tree of metrics that are connected. And then you're easily or much faster, you can put together your messaging like, I've looked at it, I see why it's happening, or at least I have a couple of hypotheses. I'm going to go back and check, and here's our new plan. And that's another thing about product managers. You have to be fast on your feet. And sometimes it's like you have a meeting in an hour, or sometimes they pull you in and you're like, okay, let's figure it out on the spot, right? So of course you want to take some of the time, not to just throw assumptions, but if you already have things handy where you know where to look, then it's going to be much easier for you to like message it professionally and not say, oh yeah, we messed up. I have no freaking idea why it's that bad, right? So you got to control your story. All right, predictive. So that's utilize models to predict the future value of data attributes. So when it comes to like those candles again, right, and the graphs that are uh, this change line, right? Like when you can see the change, then it's you oftentimes, depending on industry, you can make some predictions. For example, for me, I know seasonality of some of our products where there's more sales during, fall. And Nastya, you probably have the same thing, right? So you can predict where things drop and where things go up, at least somewhat. Like, okay, we need to have more agents stacked up for that specific period of time, or there's going to be much more users coming in, or like there's an expiration. Let's imagine, Tanya, on your app, it's a freemium, but there's maybe um, specific dates that oftentimes this is where people bought. Let's say you have for holidays, you have a sale. Like, it's 50% off to have your um, subscription, right? And so, and maybe it even has like some sort of for the first half a year. And so the first half a year passes by, and now you'll see a lot of people dropping and not signing up for, because now it's a full price, right? So these predictions, you can follow through and you can plan ahead, basically. Make sense? I just don't want to, like,
Yes.
I hope I'm not being too boring with saying something that is completely duh. I'll just keep moving. All right, so biases. Biases can lead to bad decisions. And again, you're going to have that at times. You have your vision. It's going to be sometimes frustrating because some other people are saying something that is you completely disagree with, and they might be right, they might be wrong. And if you have your own bias, so it's stepping out of your product is really, really hard. The further, like the more you are in it. Um, so uh, I will just, I'm gonna skip, but everybody knows what anchoring bias is.
I don't actually.
So anchoring bias is like the most traditional bias that you have. Let's say, especially like between men and women, you could make assumption. Well, like, oh, actually, this is a good one. For example, Nastya, in your app, you automatically went first to women, right?
Yes.
And so that's kind of like an anchoring bias because I'm a woman, and so I kind of look at things through the prism of women, right? And I think, well, clearly, this is going to be my first customer. Although maybe the not enough or untapped market is with men. There's lots of gay men who buy a bunch of accessories, and then even that is somewhat biased because there's lots of men, let's say Latina men, buy all those different jewelry and necklaces. This is kind of like an anchor. You, if you're starting with your main anchoring bias, so anchoring bias is the one that is coming from you. Meaning I'm a woman, so I assume I already know all these things and I understand what all women want. and then making all these other assumptions might limit you in making the right decision. So there's selection bias. It's us versus them, and kind of want to. I'm just looking at the time. That's why I'm like, should I be going too much into it or not? Confirmation bias, approaching analysis with a preconceived idea of what the data will say, introduces the risk of confirmation bias. So it's something that, let's say, for it's something that you've predicted or you're expecting that it will be. So you're just looking there. For example, I'm just trying to apply it to what your apps are, so that it's more applicable. Yeah, so like you're looking again, like you're looking for just you have like your assumption and you're just looking for approval or confirmation of that conclusion, and you're not broadening your spectrum basically. So that is the confirmation bias. Now I'm thinking how to explain the other bias that we started with, which is anchoring bias. I think they're very, very close because one is also saying about, this is like something that I already know of, and then which stops you from doing the entire full-on research. And the select and the confirmation bias is also very similar. You guys can Google and tell me if I'm wrong, but I think they're very, very close to each other. So evidence we ignore, facts and evidence, our beliefs and evidence we believe. Okay, so like that's maybe it's a little bit more. Maybe it's broader than the anchoring bias, because what we believe is right here, and what confirmation bias is also at least including some okay, so it's like some of the facts that we know and our beliefs, so it's a combination of those two. Okay, try to read this, right? Research indicates that the order of the letters in a word doesn't really matter. What really matters is the first and last letter in the word. If they are in the right place, you can read the words. Right? Okay. So, hold on, let me just, we had a video with like this monkey, and I'll just share it with you and you can watch it in your own time, but it's there's activity going, and then not everybody notices that there's like a completely different thing in the video, because everybody's paying attention to the main thing. And so I could say that similar things are happening in like news today, right? Like we're all looking at the like economy and what Trump says, for example, but there's also a lot of things going behind. So let's just run through the most important part, which is the exercises and samples of all these different graphs that I talked about. Okay, so this is a tree metric. But there's a caveat. There is something wrong with each one of them. So before we figure this out, I'll show you an example of a good tree map. Otherwise, how would you know? Okay, so dum. Tree map. Oh. Oh, I think this one, that's the one I was looking at. Looking at it in the morning to make sure I gave you a sample. Okay, so this is a pretty good, very simple sample. Do you see the screen that I'm sharing with the tree map? Okay, so product revenue by category. Okay, so there's beverages 46%, and then there's baked goods 23%, and then there's additional merchandise. So that would be basically 23 plus okay, 46, right? So 100% minus 46 is going to be 54, and then 54 minus 23, 31. So there's going to be 31 here. Doesn't look size-wise correctly. There's 19 here. Okay, so there's 19. So 54 minus 23, 34. So 34 minus 19, 15. So this is 15%, this is 19, and this is 23. Okay, we're good. So the color just kind of separates the categories, right? And so under beverages, let's say it's a company that's, and this is their spending. They spend 43% of their budget on coffee, which is 1,500. They have special drinks that's eating up 34%, which is 1,200. Still, so the numbers do add up. And then there's tea, 23%. And so then there's a separation of baked goods. And under baked goods, you have pastries, muffins, and cookies. And then under snacks, you have sandwiches and granola bars. And then under merchandise, you have mugs and then t-shirts. So I think it's like a coffee shop or something, right? So within one tree map, we get to see how much they're spending in dollars and also percentage, and what are the things they're purchasing. Does it make sense?
Yes.
Somewhat. Okay, sounds good. So now let's look at this little guy. Now I am going to share with you the URL because I know that this is a very hard one to read. Probably. Oh no, I don't need to put it. I just need to copy link. And then I'm just dropping it here in our chat. If you have issues viewing it because it's so small, you can just open it on your own side to read. But here we have, so like we're seeing metrics or a graph, and a good graph means you can easily read it and it all makes sense. So I already gave you a hint that this is not correct information, but there's a lot of interesting points here. It says the $1 billion O-gram 2009 figures. This is their giving. This is their spending. This is fighting. This color is accumulating, owing, losing, and earning. And there's a little star saying estimated. So first of all, so there's a bunch of different things that are wrong with it. I want you to look at it and identify what the heck it is you think. What are your thoughts? What are the good things and what are the bad things? You don't have to have all the answers. Just give me something that you are looking at in your assumptions of what it is, and we'll go from there.
I'm not
It's a
really looking,
mess.
so I will listening.
Oh, you're in the car?
No, I'm just working.
Okay. So Tanya, what are your thoughts? What is this? What are these numbers?
So I think that everything is a mess because it's a little bit difficult to understand.
Mhm.
But there's, for example, the first is the first budget and it's how much like China, UK, Saudi, India, how much they spent. Like we have in total. Okay, it's US, US and other countries. And it's like fighting. What is what after
Fighting,
spending? Fighting.
fighting, yeah.
Yeah. Ah, US defense budget.
Hmm.
So it's like how much they have for budget.
This is a US budget in the $1 billion gram 2009
Mm,
figures. This is what you see was like 3,000 billion. That's 3 trillion basically. And what they're
mm,
showing is the Iraq and Afghanistan wars total eventual cost is 3 trillion. And it has this little one, 60 billion Iraq war predicted cost, which was 2003. And so you can see that they started with 60 billion prediction and ended up being with 3 trillion expenditure on Iraq and Afghan war total. The wrong thing about it is that they have same colors, but they're for some reason separated. And also, if this is prediction, then it's not very clear what is this. Like there's US defense budget. So the budget itself was 726 billion. Did it go to like NATO or what? Because this is for their spending and this is how much the actual cost happened. Now the war didn't last for only 1 year, 2009. So we're not sure, like, did they calculate it from 2003 till 2009? It's very unclear, right? The numbers themselves are very interesting because they're true, they're correct. But the layout is wrong. There's also not like a full-on number that it all sums up to, because some of them you'll see are kind of like expenses, and some are like I think some of them might be the ones that are like earnings. Um, it also shows Walmart revenue, which is $405 billion. And Walmart profit is $13 billion. I don't know how to, you know, um, so like they basically pay taxes off of the profits or out of revenue. I don't know why is this important to us? Um, then there's OPEC revenue, which is also a government expense. Climate change fund is 3 billion. The OPEC revenue is 780 billion. And donation to charity by Americans 2008 is 308 billion. Foreign aid payment is 120. So from the government to other countries, or foreign aid basically, is 120 billion. NASA is 19 billion. So the stats themselves are freaking really interesting, but the um, showing of it is a bit misleading and not very clear. Okay, let's just move on because we have a couple of other samples. So here's another one. It's a visual, and it's another thing that we could say here is that it's kind of blurry, hard to read. But with this one, it's like almost impossible to read, and it's on purpose as an example. The traditional something of water um, quality is waste from factories and farms. Anyway, really hard to read, but the point is they're adding at least some explanation of what they're all about, and it's all about farming and the quality of water and what's in the water. And since we know that, a lot of waste goes into water, it ends up being they're trying to show like what we are drinking basically, and which kind of meds we are ending up drinking um, within that water. But again, this fish doesn't sum up to like 100%. And it's I mean, the only good thing is that it's, the 20%, it might be that it's the 20%, but then the 33% right here doesn't look bigger than 20%. So again, it's like not matching the story. So yeah, this is another bad example of what not to do. And then, yeah, Nastya, I will share the video. And then here's our pie chart, except it's pizza pie. I hope you're not super hungry, but it's mushroom is the UK's most liked pizza topping. So look at these numbers and say, knowing what you already know, the wrong things about it. The first one.
The proportion is incorrect.
The percentages are off. Like, how many hundreds are we talking about? Because it's definitely not summing to 100%.
26, yeah, 26% spinach is the same as others.
Yeah, exactly. And then if you calculate together, it's like what?
Yeah.
200-300%. But see, their message is mushroom is the UK's most liked pizza topping. So you could, like, if you wanted to say that, let's talk about how you could fix this, right? And then you have, so which toppings do you have? You have tomato, olives, pepperoni, peppers, sweet corn, spinach, pineapple, ham, bacon, and mushroom. So looking at our examples here, which one do you think would be actually better to show that mushroom is the most popular topping?
Sorry, could you please repeat?
Юра, Юра, go away. Так, okay. So you have several toppings, right? And they say mushroom is the UK's top topping on pizza. So out of these graphs, which one will you use to show it, if that's your, goal?
I think like a bar. You can show it in a bar.
You could show the bar.
Pie, of course.
The which one?
Pie.
Pie. Yeah, you could use pie. But the only thing is that it's only if you know, like there's, let's say in the survey, there was 20 people or some number, and then you break it down percentage wise. Otherwise, if you don't have the correct percentage, because we currently don't have the right percentage, it would be harder to show, But the ranking, the bar would be the best solution for you, because you just show here. In order to show it as a pie chart, you would need to go back to them and say, hey, these are incorrect. And in fact, mushroom is, okay, it is 65, so it is the highest, but like that means we only have 35 left. So where do you want to split those, right? To make sure it's actually
I
100%.
don't know. It looks like how they combine in pizza. So for example, 65% they combine it with tomatoes. And for example, if you have 100% and 65% they add in mushrooms, but also 51% added to the same pizza tomatoes. But for example, other people instead of tomato they can add like something else, like olives. I don't know. So then maybe it's if you're speaking not about pizza in total, but we're speaking about ingredients. So it
Mhm.
might be about like 100% they want this topic.
Mm. Per pizza. So like you're saying,
Yeah,
in this pizza, in this pepperoni pizza, 56% is taking is pepperoni. Could be. I mean, I like your creativity. Um, uh, again, for the goal of showing like that the mushrooms are the top choice. I don't know how else you would show it other than, it's either correcting the percentage here, or showing it in the bar. But I hear you, like you could also add, maybe like this is the most loved one because it has 65% of mushroom. And let's say if we're being creative right now, right? Or you're being creative right
it's
now.
like
You could
it's
add.
like 33% of people they like olives and they add the pizza. Like
Mm-hmm.
56% they add pepperonis. Like, but other how many 44% they add, for example, pineapples instead of
Mm-hmm.
pepperoni. So it might be.
Maybe I'm getting so hungry. I'm gonna go to another slide. I'm like, okay. Okay, we're getting closer to the end of our slides, so stay with me. You're almost there. So there's another hands-on exercise. How might we improve this chart's use of contrast? Focus your attention on size contrast, color, shape, and contrived contrast. So how baby boomers describe themselves? 40% describe themselves as leaders, 60 willing to learn, tech savvy 22%, people savvy 78%, and creative 42%. Which these numbers don't have to add up to 100, right? Like
Yeah,
you could be saying, oh yeah, like I'm willing to learn top, and then I'm also a leader, and da da da. And then it's the sets of people, just like you were talking about pepperoni pizza and other, toppings. You could be a mash of different things. But
yeah.
how could you improve, like if you basically kind of take away, just hide this man and just looking at stats and what they represent, what would you think could be a better graph to show the story and not mislead people?
I think like three. We can show it with a tree.
Yeah, I think so too. I think I have a smartphone. Don't discount my. Okay. I think so too. So, because it doesn't have to have all like 100%. You could be like your baby boomers is like the category fully. Let's see. Member of chairs use of contrast. Let's double check because I haven't done this exercise in a while. So
Or it can also be word cloud.
it could be, that would be actually also really good because then you are showing with the size of the word or of the statement, like leader or tech savvy and stuff like that.
Yeah.
But it is definitely relativity, right? And so from relativity, since the pie chart it cannot be used because it doesn't
Mm,
equal to 100, then it should be a tree map or word cloud. And I think word cloud might be even the best one. Okay, good job. And then let's see what else we have. Oh, and this is it.